Welcome to our session on testing and debugging, a crucial aspect of modern software development. Our main goal is to ensure the high quality and full functionality of every application we build. Let us begin by exploring the core concepts behind unit testing, a fundamental practice for robust applications. This involves thoroughly testing individual components of your software in complete isolation. Unit testing focuses on examining the smallest testable parts of your code, called units. Specifically, it tests individual methods or classes to verify their correct behavior. This process ensures each component works perfectly on its own, without external interference. So, why should we prioritize unit testing in our development workflow? Unit tests effectively detect bugs very early, saving significant time and resources later in the development cycle. They also significantly improve the overall reliability and maintainability of your codebase over time. Furthermore, unit tests prevent regressions, ensuring that new changes or refactoring do not break existing functionality. Now, let us look at some common Java unit testing frameworks that help us achieve these goals. These tools are indispensable for effective and efficient component testing in Java applications. First, we have JUnit, which is perhaps the most widely recognized framework. JUnit is extensively used for writing and running unit tests within the Java ecosystem. It provides excellent support for annotations and assertions, making test creation intuitive and powerful. Next, we encounter Mockito, a powerful framework designed to facilitate the creation of mock objects. Mockito is primarily used for mocking external dependencies during your tests. This helps to isolate classes effectively, ensuring that your tests focus only on the code under examination. Lastly, we have AssertJ, which offers a fluent and highly readable assertion library. AssertJ provides expressive assertion methods, making your test code more natural to read and write. Ultimately, it significantly improves the readability of your test code, making it easier to understand and maintain. Let us now walk through a basic JUnit test case to see these concepts in action. We will focus on verifying the functionality of a simple addition method. Here, we have the math utility class, which contains our target method. This class includes a straightforward method called add, which simply sums two integers for us. This Java code defines the math utility class and its add method, which calculates the sum of two numbers. Next, we will see how to write a JUnit test specifically for this addition functionality. The test addition method is conveniently marked with @test, indicating it is a JUnit test case. This code demonstrates a JUnit test for the add method, asserting that 2 plus 3 equals 5. Let us now explore how to enhance our tests even further by using Mockito effectively. Mockito helps us isolate components, allowing for more focused and reliable testing. So, why exactly should we choose to use mock objects in our testing strategy? Using mocks avoids making actual database or network calls, which can be slow and unreliable. This approach significantly improves test performance by removing external dependencies. Mocks also ensure consistent test results because they are free from unpredictable external changes. Now, let us examine the core functionality that Mockito provides for our testing needs. Mockito excels at creating mock objects for any dependencies your class might have. It allows you to define specific behaviors for these mock methods, simulating various scenarios. Finally, Mockito enables you to verify interactions with your mock objects, ensuring methods were called as expected. We will now apply Mockito for testing a service layer, a common scenario in application development. Our goal is to simulate repository behavior to effectively test the user service class in isolation. Here, we have our user service class, which relies on a user repository for data access. The user service depends on the user repository, and Mockito will simulate its behavior during our tests. This Java code defines the user service class, which depends on a user repository to fetch user emails. Now, let us look at how we can implement testing with Mockito for this user service. The mock method creates a mock object. When then return defines its behavior, and verify ensures the method call. This code illustrates a Mockito test case for the user service, simulating the user repository's find by ID method. Next, we will discuss Postman, an API testing powerhouse that is widely used by developers. Postman is instrumental in streamlining API development and debugging processes efficiently. Postman offers a highly intuitive interface, making it very user-friendly for all levels of developers. This allows you to test your APIs thoroughly without the need to write any code. It provides comprehensive HTTP method support, covering all standard request types. Postman efficiently handles GET, POST, PUT, and DELETE requests, giving you full control over your API interactions. Furthermore, Postman facilitates API automation, which is vital for continuous integration. You can automate your testing workflows effectively by utilizing Postman collections. For secure access, Postman offers robust support for various authentication methods. It supports JWT, OAuth, and API keys, ensuring your API calls are properly authenticated. Now, let us delve into effective debugging strategies for identifying and resolving code issues. These techniques will help you efficiently pinpoint and fix problems in your applications. For front-end debugging, several powerful tools are readily available to us. You can effectively use browser dev tools along with console.log and debugger statements. When it comes to back-end debugging, our approach shifts to different but equally effective tools. Here, we leverage structured logging, IDE breakpoints, and robust global exception handling mechanisms. For API debugging, a critical area, we have specific strategies to employ. We use Postman, thoroughly check the network tab in our browser, and analyze HTTP status codes. Finally, addressing database debugging requires a focused set of actions to diagnose issues. You should enable SQL query logging and carefully verify all database connection properties. We will now explore automated testing within CI/CD workflows, a vital practice for modern development. This ensures consistent code quality throughout the entire development pipeline, from commit to deployment. Unit testing is the foundational level, where we test the smallest isolated parts of our code. This involves testing individual methods and functions to ensure they perform as expected. Next, integration testing verifies how different components interact with each other. This specifically verifies API endpoints and their interactions with databases. End-to-end testing takes a holistic view, testing the entire application flow. It simulates real user behavior across the entire application, from front-end to back-end. Performance testing is crucial for understanding how our application behaves under stress. This assesses the application's scalability and responsiveness when subjected to various loads. Finally, security testing is paramount to protect our applications from vulnerabilities. This process identifies potential security vulnerabilities before the application is deployed to production. Let us now look at automating tests using GitHub Actions, a popular CI/CD tool. We will examine a sample CI/CD pipeline configured for a Spring Boot application. The first crucial step in our pipeline is to get the project code. This action efficiently checks out your repository code, making it available for subsequent steps. Next, we need to correctly configure our development environment for Java. This step sets up the Java 17 environment, ensuring compatibility for our Spring Boot application. After setting up Java, the next logical step is to install all necessary project dependencies. This command runs maven install to download and prepare all required project dependencies. Once dependencies are installed, we proceed to execute all automated unit tests. This command runs maven test, which executes all defined unit tests within your project. Finally, after successful testing, we build the application package for deployment. This command runs maven package, creating the deployable artifact for your Spring Boot application. To summarize our discussion, let us review the key takeaways from this module. These are the most important points that you should remember from our session. JUnit and Mockito are the industry standard frameworks for effective Java unit testing. Postman remains an indispensable tool for robust API testing and thorough debugging. Selenium and Cypress are powerful frameworks that enable robust end-to-end UI testing. Debugging effectively involves using dev tools, meticulous logging, setting breakpoints, and handling exceptions. Automated testing integrated into CI/CD pipelines ensures continuous quality and accelerates deployments. Remember to use Newman for automating postman collections and GitHub Actions for workflow automation.